The topic is de Broglie wavelength of electrons. Okay, so this is your topic. So take the page number 124. So in that, let an electron of mass m be accelerated through a potential difference of volt v. The kinetic energy acquired by the electron is given by, okay, that is of mv square is equal to electron volt. So when I give the potential difference, the electrons, if it is in a moving condition, that electrons also will experience the kinetic energy. So for that, you can write of mv square, that is equal to electron volt. So this V, it clearly denotes velocity of the electron, and this V, it clearly denotes potential difference. Okay, potential difference. So in this, just I am going to modify this equation, okay, to find out the speed of the electron. So take the speed of the electron in the sense velocity of the electron. So V is equal to, which means V square, I'll keep V square and I'll take this 2 to the right hand side. So it will become 2EV and this M to the denominator, because multiplication will be in the division and the division will be in the multiplication. 2 the division leg. So it goes for multiplication, and this multiplication m, it comes under the division. So I will get m. Okay, and take this root to that side. So I will get 2EV divided by m. So this is the de Broglie wavelength of the matter waves associated with the electron. So to find out the wavelength, we will use the symbol lambda. Okay, so we know that lambda is equal to Planck's constant divided by the momentum. I can write this mv as an p or mv. Okay, I can write in any way. Okay, so lambda is equal to h by mv. So I have the velocity of the electron, mass into velocity, no? So velocity of the electron, I have the equation here. So just now I find out this equation. So lambda is equal to h by mv, means just substitute the value. Lambda is equal to h divided by m as it is I wrote, and remaining what is the v value? Root of 2EV divided by m. Okay, so so this m is in the root. Okay, the denominator m, it's in the root. So I'll write it separately, then only you can able to understand. H divided by, okay, sorry, lambda is equal to h divided by root 2EV divided by root m. Okay, but here I have 1 m extra. Okay, so when I cancel this root m and this normal m, I'll have the root m here. Clear? So I can write this equation as lambda is equal to h divided by root of 2EV. This root m no, so I am writing it inside the root. Okay, so now, so this is your final conclusion of this topic. So now we are going to substitute the values in the above equation. So the lambda is equal to, so see in your book it's very clear, lambda is equal to 6.626. Okay, here you can see lambda is equal to 6.626 into 10 to the power minus 34 is the Planck's constant value. Okay, this one is the Planck's constant value. Can you see or not? I don't know. Sorry. Okay, so this 6.626 into 10 to the power minus 34 is the Planck's constant value, and the 2 volt I kept as it is, 2V I kept as it is, and the electron value and the mass value. Okay, just you substitute and manipulate it, you will get the root V alone in the denominator. Why means root V we don't have any value to substitute. So if in case in the problem, if they give the root v value also, you need to find out. Okay, that is the volt value. Okay, so to convert the meter into Armstrong, I have written 10 to the power minus 10. Okay, it will be changed. Okay, it will be cancelled because I am converting it meter to Armstrong. Okay, so 12.27 divided by root v Armstrong is your answer. So for example, they gave in your book. Okay, wait. Yes. So for example, if an electron is accelerated through a potential difference of 100 volt, then its de Broglie wavelength is 1.227 Armstrong. So since the kinetic energy of the electron K is equal to electron volt. So number, we can write of mv square, which is nothing but the kinetic energy. So I can directly write kinetic energy is equal to electron volt. So I can replace this equation. Instead of writing this electron volt, I can apply K here. So the formula will be termed into lambda is equal to H divided by 2m, then the kinetic energy in the root. Okay. So this is the de Broglie wavelength of electrons. Okay. Thank you.